In this video, we will continue practicing doing combinations of transformations. And if we do multiple transformations, instead of just going from example h to h prime, that would be one transformation. If we do two transformations, we have to go to h double prime. And if we do three transformations, it will get to h triple prime. Okay, we've already done problems 1 through 9 in a previous video. All right, so we're going to pick up here with number 10. A quadrilateral RAPS is located on these vertices. Where will the points R double prime, A double prime, S double prime be located after the quadrilateral has been reflected across the line y equals x and then rotated 180 degrees around the origin? First of all, let's write down the rules. If we want to reflect across the line y equals x, okay, so the first thing we're going to do, so step 1 is going to be to transform each point x comma y into the point y comma x. All right, that's your reflection across the line y equals x. You reverse the coordinates. And then for step 2, the second transformation, that's when we're going to do this rotation of 180 degrees about the origin. Well, when you rotate 180 degrees, all you do is change the signs. You don't reverse the coordinates or anything. You just change the signs. So that would be like xy becomes negative x, negative y. All right, so you have to memorize things like that. You have to memorize everything on this list. Okay, and we just did this one and this one. All right, so with that in mind, let's get started. So we have the point, you know what, I think I'm going to copy down these 4 points off camera. So here are the original points RAPS. So first we're going to reflect across the line y equals x, and that will give us r prime. Okay, so we're just going to reverse the coordinates. So that's going to be 1 comma negative 4. And then a prime is going to be 4 comma negative 3. And p prime is going to be 5 comma 0. And s prime is going to be 1 comma negative 1. So we just switched x and y. We reversed the coordinates. Okay, so now let's see what we should get for the final answer. Now is when we will do our rotation of 180 degrees. And that's where you simply change the signs. Okay, so that will give me r double prime. I'm just going to change the sign. So this will be negative 1, positive 4. And a double prime is going to be negative 4, positive 3. Simply change the signs. P double prime should be negative 5, comma 0. The opposite of 0 is still 0. And s double prime should be negative 1, comma positive 1. I just changed all the signs. And this should be the final answer. So let's start with the ones I can see on screen here. R double prime should be negative 1, comma 4. Nope. So it's not C. What about D? I see negative 1, comma 4. Okay, then A double prime should be negative 4, comma 3. So far so good. P double prime should be negative 5, comma 0. And S double prime should be negative 1, comma positive 1. Yay! The answer is D. All right, so that's it for number 10. Number 11, describe the reflections that would transform the rectangle onto itself. Okay, they're saying what reflections could we do that would not change the look of this rectangle. It would give us the same picture back again. If I reflected over this red line that I just drew, that would give me the same point, the same rectangle back again, because this point up here would end up down here. And for example, this point down here would end up right here. These, the top half of the rectangle would just switch places with the bottom half, but it would look the same. So this is the line y equals 2. Okay, that's the line y equals 2. So reflection over y equals 2 would transform the rectangle onto itself. Okay, what else though? All right, that would work, but that's not the only one that would work. What about a vertical line through the middle of this guy? Okay, wouldn't this do the same thing? Okay, and again, the reason why this would work is because, for example, this point would end up right here if I did this reflection. And for example, this point would end up right here. The entire left side of the rectangle would end up where the right side is, and the right side would end up where the left side was. Okay, so it would still look the same. So this is the line x equals -1. All right, a vertical line at -1 is x equals -1. So reflection over x equals -1. Now, these are the only two answers, all right? These are the only two lines of symmetry for this rectangle. So very often, I will have a student try to say that this diagonal line right here will also be an axis of symmetry. All right, they'll try to say this. Okay, well, let's test that out. Let me see if I can convince you why this is wrong. If this were going to be another situation where half of the rectangle would reflect back onto itself, then, for example, this point right here should land on the other corner when I do the reflection. Let's see if it does. Remember, when we do a reflection over a diagonal line, well, you know what, this is not a 45-degree angle, so let me pause because I have to be careful. Okay, there is no just really precise way I can do this because I can't just count squares like I do when it's a 45-degree angle. But what I can do is I can measure using this line segment how far this is away from the line. Now I'm trying my best to make this perpendicular. See how this would not be perpendicular and this would not be perpendicular? So when I measure this distance, I'm trying to make it as close to perpendicular as possible. Okay. Let's see. I think I will change the color as well. Okay, now I've duplicated it. All right, so if I continue that same distance to the other side of the line, that is going to show me about where the reflection should be. Okay, so the reflection of this green point should be very close to here. Now you see how that is nowhere near the other corner of this rectangle. All right, now if you still don't believe me, take a sheet of paper, you know, in 8.5 by 11, it's a rectangle. Try folding that paper along the diagonal and see if the corners match up. I think you'll find that the corners will not match perfectly. You're going to get like this type of deal. Like one side of it's going to look like that, and one side of it's going to look like that. All right, they're not going to match. All right, so these are the only two answers. This a diagonal line is not a axis of symmetry. It's not a reflection line. All right, let's jump over to number 12. Describe the rotations that would map the triangle onto itself. Okay, now notice that a rotation around the origin will not map this rectangle around itself, because this rectangle is it's like high and to the left of the origin. If I turn this upside down, it would be low and to the right. So it would not fall in itself. But if I rotated around this dot in the middle, if I use that as the center of rotation, then the rectangle will match back up with itself. So the only question is, how many degrees? Okay, I don't know if it'll let me demonstrate this or not, but okay, here is a rectangle. Will it let me rotate it, is the question. I think that it will not, but I'm going to see. Okay, how many degrees? Can I do a rotation? Okay, if I were to rotate this 90 degrees, can you see that this does not match the original rectangle? All right, it's going off the side, so 90 degrees will not do it. What if I rotate another 90 degrees? Bam! So if I just rotated 90 degrees twice, how far did I really rotate? Hopefully you just said 180 degrees. So that's the answer. Rotate 180 degrees around, and this center is the point -1, 2. Okay, is there anything else that would work? Well, what if I kept going a little bit more? All right, what if I rotate again? All right, if I rotate 90 degrees 3 times, that's 270 degrees. That doesn't work. But of course, if I rotate another 90 degrees, that will put me all the way back around. So, of course, rotating 360 degrees will always make an image match itself. Will always map an image onto itself. So rotating 180 degrees will work, but also if we rotate 360 degrees around the point -1, 2. Those two rotations would map the rectangle onto itself. All right, problem number 13 is walking us through a double transformation, 2 reflections. So first we are to plot triangle ABC on the coordinate plane. So here we go. -5, 1 would be right here, and -3, 6 would be right here, and 2, 3 would be here. All right, so these are the coordinates of triangle ABC. Next, we are to reflect this triangle over the line y = 1 and find the coordinates a prime, b prime, c prime. Remember, y equals a number is a horizontal line. So y = 1 is going to be a horizontal line at 1. And you should represent this as a dotted line. Okay, so this is the line y = 1. All right, it's a little bit hard to see. Maybe I'll... Okay, so here's the line y = 1. We need to do a reflection. Well, notice that the point A is on the line y = 1. If you're doing a reflection, any point that is on the reflection line is not going anywhere. So A prime is going to be right here. Now, what about point B? So point B is 5 units above the line. 1, 2, 3, 4, 5. So I need to go 5 units below the line, and that is going to be B prime. Point C is 2 units above the line, so C prime will be 2 units below the line. So there's the image after reflecting over the line y equals 1. Now we need to write all of these coordinates down. For example, A prime is the point negative 5, 1. B prime is the point negative 3, negative 4. And C prime is the point 2, negative 1. Alright, I'm just going to copy all those points down right here. So there's your A prime, B prime, and C prime. Next, we need to reflect these points over the line x equals negative 2. X equals a number is a vertical line, so let's draw a vertical line at negative 2. And again, you should draw this as a dotted line like this. So here is the line x equals negative 2, a vertical line at negative 2. So now I need to reflect each of these points, A prime, B prime, and C prime, over this vertical line. Let's start with the point A prime. A prime is 3 units to the left of the line, so I need to go 3 units to the right. So this will be a double prime. Let's see. Point B prime. B prime is 1 unit to the left, so that means I need to go 1 unit to the right. This will be B double prime. Now point C. Point C is 4 units to the right, so its image will be 4 units to the left. So this will be C double prime. So this purple triangle is the image after the second reflection. So now I need to just copy down A double prime, B double prime, and C double prime. Okay, A double prime is the point 1, 1. B double prime is negative 1, negative 4. And C double prime is negative 6, negative 1. So there's the answer for part C. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.